to this computer. As I said, today we are going to continue with the bash scripting, and we are going to talk about something called the normal flow of execution. And what is it? And what if we don't want to follow the normal flow of execution? Well, simply, we have two other styles, if you will. One of them is called the selection structures, using selection structures, and the other one is called using repeating structures. Now, I'm pretty sure most of you guys already have a programming class before. So today, the content of today's class, it's not going to be brand new for everybody. It's just something I'm pretty sure everyone here have done it before. But we're just going to learn how do we get this specific topic that we're covering today done in Linux operating system. So let me start immediately by sharing my screen. And we can start today's class. Simply again, today's class is called using structured commands. Okay. Now, before we jump into the main topic of today's class, there's one specific element that we need to understand before we jump into what today's class is all about, and which are the standard inputs, standard outputs, and stand-up errors. Now, what are these standards? Simply, again, every time you issue an operation where something needs to be printed on the screen, the standard output object is simply going to be called. And the standard output object, again, in Linux operating system is simply the terminal monitor that you see here. So when I type echo test, again, this is the work of the standard output. It's simply showing the text test on the terminal. Now, whenever I want to perform some input operations, which is something we're going to talk about now, let me just here. When I typed echo itself, that's the standard input is working. Whenever you perform any input operations, that's the standard input operation working. And the default device for the standard input is simply the keyboard. Okay. And in a lot of cases, we can actually have, other than the screen, the terminal window to be the standard output device, and we can also have other resources instead of the keyboard to be the standard input. But this is not what we're talking about today. I'm just going through the standard input and standard output. But the point here, what I'm trying to say here is that we have the standard input, we have the standard error. Now, the standard error is simply going to be triggered every time something went wrong, an error message needs to be printed on the screen. Okay, so let me just give you an example here. I want to type a command where it doesn't exist. So if I say pwd, that's what we know. But if I type pwa, this is again the work of the standard output. It's showing me that the command not found. Okay, then the default application for the standard output is also the terminal window that you see here. Now, why am I saying this? Because this is going to lead me to the second point. We can redirect, and remember here, we can redirect the outputs, and instead of being shown on the screen, we can redirect them to be printed on a file. So, for example, if I type echo test, and this is something we covered before, and I just direct it to new file dot text. Well, let me just call it file1 dot text. And now if I type cat file1 dot text, you can see it's print test there. Now let's do the same thing with the PWD. PWA, which is the one that is supposed to show me, and again, I made a mistake here. I can redirect it also to file. Oh, wait a minute. File dot text. Oh, he didn't like it. I'm pretty sure, yeah. Let me try to figure out a different types of errors. Let me go with ls, lsl, and if I type ls -l, and I will go, for example, file.text, it will show me the information file text. Now, of course, I can repeat that by sending the output to file 1.txt. And now if I go cat that, you'll see what I have here. Now let's try to do this. ls-l, and I'm going to go file 2.txt. Now again, if you print that, they tell me that file no such a file. Okay, that's again the work of the standard error. Now what I'm going to try to do in this case is to redirect that to file 1.txt. And look what's going to happen here. Well, it kept showing me the message, but let's go ahead and cat file 1.txt. And where is that? There's nothing there. That is weird because I thought it should actually show me. What I'm trying to do here is I can redirect the errors just like how I can redirect. Oh, wait, sorry, my bad. Let me just clear the screen. And let me open the chat box just in case somebody's typing anything so I can see it. Okay. Let me just go back and rephrase. The standard error, again, you cannot redirect it. That was my mistake. You cannot redirect it. The message will not be simply printed there. That's my point. But again, here we can redirect those messages. Again, we can redirect them with the standard outputs to a file, text file, but we cannot do the same thing with the errors. My bad, that was my mistake. I just totally forgot about that. Okay, now why am I saying this? Why am I saying this? Because there's a technique that we can actually redirect the outputs of the standard input and standard errors to one specific file that is located in the operating system. And that file, again, it's located in a folder called div inside a file called null. Okay. Now the div/null file, think about it as the black hole that whatever you throw in it, it just disappears. Now, again, why would I want to do that? There is a reason. Well, we're going to get to that point. But let's go ahead and demonstrate that. So if I type ls again, -l, and print all the files that I have here. And you know what? Let me just get out of here. And I'm in faculty. So if I type ls, oh, wait a minute, ls-l, you can see here that these are all the available folders that we have in that directory. So if I type ls-l, ljanab, oh, wait a minute, why am I here? Oh, he went inside, okay, inside the ls and showed me all the files that I have there. Okay, now I can apply the same thing for other users. For example, let's go with jki, and he showed me now the folders and the files inside that folder. Anyway, let me show you what can happen if I type the following. If I redirect this output, again, remember here, I can redirect it to a file if I want to. So all the information that you see here simply will be printed into the file, but I can also redirect it to that null file. And whenever you're going to put it there, simply it's going to disappear and it's not going to appear on the screen, and it's not going to be stored inside a file as well. So let's just navigate and see where's the location of that div file. So if I go cd and we get out, let's go back to the main. Now if I go here, the div is supposed to be somewhere here, and I can see it here. This is div. So let's change again directory to home, change directory to faculties. And now in faculties, if I list them, here they are. And I'm going to go again to my original message, ljanab, and then I'm going to redirect it to div and null. And you can see here, nothing was printed. So the whole point of what I'm trying to do here is to show you that you can actually send your output to this null file. And again, this null file again is just simply going to take it and disappear. Why am I doing that? Again, there's a point that we're going to get to it in a sec. Let's try to do the same thing now with an error message. So instead of algebra, let's just put a name that doesn't exist. Like, let's say Bob. Well, the whole point here is that Bob knows such a file or directory. I'm trying here to make sure that the message will not appear on the screen, but for some reason it's actually showing on the screen. Let me just double check this. Okay. Okay, there's something that I'm not sure. Oh, I just realized what's the problem. My bad. My bad. Whenever it comes to error messages, whenever it comes to error messages, and let me just clear. Let's go back here. Whenever it comes to redirecting error messages, I don't know how did I forget about this. You need to tell me what is the number that represents the standard errors. And in this case, it's simply 2. Okay. So instead of just greater than simple, you have to put the standard error number, which is 2. And I think standard output is 0, standard input is 1, and standard error is 2. But with standard inputs and standard outputs, we don't have to put the numbers, but with standard errors, we have to put the numbers, which is 2. Let's give this a try, and you can see here now the message is not shown on the screen. So let me just recap what I was talking about since the beginning of this class. Whenever you have an output, simply the standard output shown on the screen, the terminal screen. Whenever you have standard error, again, the standard error is going to simply show it on the screen. You can redirect it to files, okay? And I'm pretty sure I can redirect this one to a file if I want to, but I just forgot to put the 2. And I think the PowerPoint maybe didn't put the 2 at the beginning anyway. So you can redirect the outputs. Now, instead of redirecting your outputs to a text file to store the message, we can redirect it to the div/null, which again, as I said, acts as a black hole that takes everything and it just disappears inside it. That's simply what I want. Now, the question is, what if I have a command, sorry, and that command, I'm not sure, let me just put it this way, I'm not sure if it's going to show me if the command is going to execute with no errors and show me the results, or is going to execute with an error and show me an error message. For example, again here, if I just type ls-l, those are all the users that we have in this folder, all the directories. Now again, I can type ls-l, and at this point, and I want you to pay attention here, I want to put a folder name, for example, JCCC. Now, at this point, if you imagine I don't have access to this folder and I cannot see inside it, there's 2 possibilities here. JCC could exist and JCC can not be there. So in a case like that, if I want to redirect it to the div/null, well, it will work if JCC actually does exist in the folders and is simply going to take whatever files inside it to, instead of showing to me, is going to simply send it to the null file. But if JCC doesn't exist, I'm going to still see the error message. So in a case like that, and this is extremely important, we have a choice here. We don't know if we should put 1, 0, sorry, if we should leave it without a number or should we type 2. Now, to solve this problem, we simply can use the ampersand, and this will cover both cases. If it's a standard output, then it's going to be sent to null. And if it's a standard error, it's also going to be sent to null. So you can see here, if I run it, no problems. And let me just put my name this time, my folder. And it's doing the same job. So at this point, what I want you to know is that this command here, we are going to use it a lot. This technique that I just explained to you in this chapter, we're going to use it a lot. The whole point here is that we're going to run a lot of commands, and in reality, we really don't care about the content that's supposed to be printed as much as we care about, is that file or folder does exist or doesn't exist. And again, if you have a command and you want to run it for the sake of running it, and you don't want to see the results on the screen, as I said, you can send it to a file, but this is again just you accumulating data that you don't need, creating files that you don't need. So instead of that, if the data, piece of data that's simply useless for you, send it to and redirect it to the null. And because there are two possibilities for the outputs and outcomes of this command, that you may get a real output or you may get an error message, then we need to redirect it simply using the ampersand greater than. With that being said, we can put this in behind and start talking about what today's class is all about. And let me just move to my faculty, my folder. If I go ls, last time we talked cat second one, and this was the file that we created last week. And this file here simply presents what we call the normal flow of execution. Normal flow of execution simply means that this script is going to be executed line by line, starting from the line at the top all the way to the line at the bottom. By the time line 1 is done, you go and move to line number 2. When you're done with executing line number 2, you move to 3 and 4 and 5 and 6 and 7 all the way to the end. This is again what we mean by the normal flow of execution. Now, today we're going to talk about selection structures. Selection structure simply means that you can have your script with many, many different lines, and you can decide when you should run, let's say, a group or a block of commands, and when you should ignore those blocks and run some other commands. Now, in a simple way or a simple form, this is us talking about the if statements and bash scripting. And I'm pretty sure here, all of you, if not most of you, all of you, I'm pretty sure all of you guys already have a background in programming in general. So today we're going to talk about the if statement in bash and how does it work. Now, let's go ahead and remind you about how do we create script file, touch. I will call this one third file.sh. And now after that, I am going to change the privilege so I can execute it. Third. And now after that, vim, third file. And now we have access. Let's go to insert mode. And then again, remember here we start with and then bin /bash. And let's just echo this. Okay, the color code telling me that everything looks good. So before we jump into how do we utilize the if statement, we need to know and we need to learn about the syntax of if statements. And the idea here is very simple. You start with the keyword if, and in this area you're going to type your command. Now remember here the command. Now I'm gonna say this, and this is very, very important. When you put a command here, there are simply two outcomes of that command. The command could execute with no errors, or the command will execute with errors. If the command is executing with no errors, the exit status is going to be 0, and this is something we covered the last thing in the last chapter. And if the command was executed with an error, then the exit status is going to be 1. So what we're concerned about here, if after executing the command, the exit status was 0, which simply implies that the command was the command was executed with no problems, with no errors. If that's the case, what do? We go and you know what? Let me just try it here. Just PWD. And then I'm going to explain this in a sec. You type then, and then after that, you type what do you want to do? For example, echo test 1. And then after that, you have to end it with if I. Now, this is just a practice that is recommended. Whenever you have a block of if statement, give it a tap. Let this command here a little bit show off a little bit. So you would know that this is, again, the if statement. This is the code. This is a block of code. Let's go enter. Let's exit. And before I save it, let me explain what I have. I said if PWD. Now, this doesn't make that much of sense, but this is just for the purpose of showing the syntax of it. So if the command, oh, you know what? Let me just add something. Echo. Let me echo the end. Okay. If PWD was executed with no errors, the exit status is going to be 0. And then if that's the case, echo test will be shown on the screen. If that command was not executed and there was an error that was produced, then, and I want you to pay attention to this, then the exit state is going to be 1, and this command will not be executed, and then you will only see the end. Now, again, this is for the testing purpose only. So let's get out of here. Save and quit. And let's, WD, yep, I'm in the right place. Let's try to run it. Let me try to remember here. We type. All right. So that's my home directory. And then we call the third one. Bad interpreter, no such a file or directory. Huh. What am I missing here? I always have this at the beginning of each class. Yep, that's my home directory. Let me just get out of here. If I go here, so here we go. /home, /faculty, /Elginavi, and then they call it third. Oh, here. Now it worked for some reason. Okay, so we can see here, test 1 was printed and the end was printed as well. So let me clear it. Let me try again. And you can see here, it's working. It's showing me the results that I know that I should have. Let's go back to the file itself. Change directory. Okay, now if I go back here, here's my file. Let's go back to the Vim third file. And let me change this to be a command that will produce an error. Oh, this is supposed to be an I, okay. And let's leave and let's save. And let's try to run it again. Okay, the same error. Why are you doing this? Let me try to take home /away. No. Does that mean I have to go backward every time? Okay. If you want to be that guy, I'm pretty sure I can figure that out. But I just don't want to spend a long time here. So let's go ahead here and put it back again. And here we go. So look what just happened. Number 1, I got the error message again printed. which again is something that I don't want it to be printed. And then I get the end. This is again the error message. So the example that I just showed you here, and let me just go back here and type vim, just to tell you that this is the structure, and whether the command will be executed or not, whether the command will be executed or not, the result of PWD or PWA, whether it's an error message or the actual outcome of that command, will be printed on the screen. But again, the difference here is if the command was executed with exit zero status, that simply means we have no problems, no errors. Then test one was printed, but when there was an error, I still got the error message, but test one was not printed. Now, this is where it's a really good idea to redirect div null, so you don't see the outcome of this command. Okay, and I want you to pay attention because this is something we're going to be repeating a lot. So let's go ahead and save our work. WQ, and let's run it again. And you can see here, test one. Let's go back and try to make a mistake. And let's quit WQ. And let's make a mistake. Oh, we did not make a mistake. So let's look here. Only see the end. Print on screen. So this is again a very simple demonstration of how the simple if then statement works. Now you need to pay attention because a lot of people forget about this fi, which again defines, remember here, if you put your command, then an fi represent the block that's going to be executed if the command at the beginning of the if statement will be executed with an exit zero status. So let's just put this in actually a real example where it could complete something that is useful. What I'm going to do at this point, let me go back. Am I in the insert mode? Yes, I am. Let's go back here and change this one to be, and instead of this, we'll go with ls-l. And I'm going to go to my home directory. Let's see here. Home directory. And I will put my name, my directory here. Okay. So what am I saying here? I'm trying to, and I think I might need to put a backslash. No. Version of ALS. Let's have one that is not in the folder and see what's going to happen. Bob. And actually, I could create a variable for that, and I will say the path. Since path is a very important, I'll go my path equal Bob. Okay. And here, instead of type my path, let's see what's going to happen. Now, if that path does exist or doesn't exist, let's say if it does exist, I'm supposed to see test one printed on screen. I will just put it here in a format, and we'll just say it's a variable. So we'll just put the $sign, and we'll say my path does exist. Okay. Now, instead of this, let's just go and put one that actually does exist. So al-janab. And let's save our work. And let's give this a try. Oh, that didn't work. I kind of knew it. I kind of knew it. That's not going to work. Let's see why. My path al-janab, I think. Let me go out. If I type pwd, oh, it's just backslash. Let me see. If I type cd directory, it took me there. So now if I type pwd, yeah, I have to be in a specific folder for me to be able to do that. Because if I go cd out, and now if I pwd, it's telling me where I am exactly. So backslash, I have to actually put the full path to it for it to work. Especially that I'm running it from the root directory. So let's go ahead and do that. And ls, so this is the root directory, so it's gonna, I have to go, let me just go ahead and do that really, really fast. So I have to come here, put I have to put home faculty algebra. So this is my path. And I'm going to test it and see if it does exist or not. And let's save it. W. And now let's just clear before I do anything. Now let's give it a try and see if I can run it. And it's still not doing what it's supposed to be doing. Huh.
I think in the if statement, if you go into the file, I think you forgot the dollar sign in the for
Oh,
the
yes,
behind my
yes,
path.
yes, yes, yes. Exactly. Thank you so much. The dollar sign. Let's go ahead and save that. Let's try it again. And here we go. So the file does exist. Okay. Let's go back and put a folder that doesn't exist. For example, let's put Smith. And if I exit WQ, now if I run it, you just see the end. Okay. So let's go back here to the Vim and let's just talk about what we just did here. The purpose of this program is simply, again, to check if a folder does exist with a specific path in your Linux operating system. And this is something you'll find yourself doing a lot. You're going to want to check for it. Existence of a file, existence of a directory, especially if you're trying to move, trying to copy, trying to get something done. You need to make sure that that file does exist. And you want to take an action based on the outcomes of that question that you're asking. So this is, again, how the if statement simply works. The syntax is, again, very simple. If, then, fi. Between the then and fi, simply you're going to have to print or type whatever you want the program or your script to perform if, again, the exit status of the command is 0, and that simply means it was executed. And this part here that I'm highlighting, again, we only do that because we are really not interested to see what's inside Smith file if it does exist, or the error message that's going to be printed. We're not interested in that, so we just redirect it to the null file here. But in general, we are interested to know if the outcome of this command has an exit status of 0 or exit status of 1. In case the exit status of 0, that's simply going to be treated as if the expression here or the command here is executed with no errors, and that is true. So you will see the message here. If the execution was simply with an exit status of 1, that's simply going to skip everything you have here and just simply move to the end file. Now, with that being said, you may ask, well, would it be better if the user will be shown two messages, one of them if the file does exist, and the other one if the file doesn't exist? And the answer will be yes, that will be the case. And to do that, it's very, very simple. All you have to do is, let's go to the insert mode. After this command, again, that the path does exist, you come here and type else, and then you type whatever you want it to happen. And in this case, my path does not exist. So what's going to happen here? What makes this one a little bit different? Well, it's very simple and very straightforward. If this command was executed with exit status 0, that simply means it was executed with no errors, then you will see this message printed on the screen. But if it was executed with an exist status of 1, simply means you will see this message printed on the screen. So you have a case for whether the statement was executed with no errors and one with errors. Okay, so if we want to give this a try, and I'm pretty sure I should see the path doesn't exist. So he's showing me that message and the end. And if I go back and actually change the path to actually exist, uh, it should work with no problem. You can see here, does exist. So the purpose of this script, again, is simply to check if a path with a specific directories does exist in the system or not. And that's pretty much what we did here. Okay. Is there any questions so far? Okay. Now, we do have a command. Now, we're going to just move on and talk about more examples about how do we utilize this if else, if then else, fi structure. We have a command called is_log_ends. Okay. And is_log_ends command simply will show me a basic user information about a specific user that we have here. So let's just go ahead and type log ends, and I'll put my name. And here we go. You can see all the information for the user ALGNAP. And you can try it by yourself as well. Now let's try with a user that doesn't exist. I'll call it XYZ. And simply nothing will be printed on screen because that user simply doesn't exist, so no information will be printed on the screen. Now, what we can do, we can actually write a script that will check if a user does exist in the system or not. So if we type, just like how we did logins, let's go ahead and do it actually here. And let me go all the way to the bottom. And I'm going to echo a screen breaker or divider. And I'm just going to come here and just type if ls list log ends, and I'll type my name, for example, L Janab. And again, remember here redirected to div null, and it will type then. Let's echo. And I can actually, instead of going with that, I'm just going to go and create a user, a variable. We'll call user equal al janab. And here we'll use user. Let's call user 1. And instead of using one specific $ user 1, and we'll just come here and say $ user 1 does exist. And of course, I can do the same thing else, echo $ user 1 doesn't exist. And then, of course, fi, don't forget it, and echo the end again. Okay, let's go ahead and leave W. And let's go ahead and give this a try. And you can see here, LGNAP doesn't exist. Oh, look at me, because I typed triple A. So that's a good idea. Oh, that's a good thing. Let's go ahead and fix that. And if I go back here and replace this with, take one of the I's away, WQ, let me clear. And now, if I run it again, you'll see that it does exist. So you can see here that I was able to check for the existence of a path in my operating system. And I was also able to exist if a user does exist in the operating system. And you can see here that how useful this will be now. Not necessary now, but later in the future, when we're going to type scripts again to get something done, we are going to do a lot of tests before you can take any action. You have an operating system that you don't really know about the structures of the file. And you want to check, for example, if a certain user does exist. And if that user does exist, you want to take an action. And if he doesn't exist, simply you want to, I'll give you, for example, if you want to create a script that will generate or create a new users for your Linux operating system. So you'll be giving the name of the user. Here's the thing, you have to check if that user does exist in the system because you're not allowed to have two users with the same name. So if that user does exist in the system, simply you should show an error message and ask the user to try with another user name. But if that username doesn't exist, okay, that simply means you can start writing the command to generate a new user and setting new passwords for that user. So you can see here, where's the point of all of that. Okay. Um, and just to let you know that there's a lot of command that will show you information about users. Um, one of them, in let's just say a list log ends. Oh, this is all the logins, so I have to type one specifically. I can type finger, and I'll put AL Janab. This will show me a little bit more information again about me. A little bit more compact version of is logins. Now there's a third one, but I don't remember it exactly. That will also show you information about a command. Squeezing my brain trying to remember it. Show you again, same different type, same information, a little bit different format. Anyway, that's not the point. But again, this is again a different technique where you can simply again check if if a user does exist. Now, just like how in programming, we can also have in Bash script, we can also have something called nested if statements. And nested if statement simply means that you may have an if statement that is inside an if statement. Okay, now let's start with something very simple, and then we'll take it from there to a little bit more advanced topic. So let's go ahead and go back to the Vim. Sorry. And here's my file. Let's go and put a new divider. And what do I want to do? Let's do the same thing here. Let's say I am going to check for a user if a user does exist or not. You know what? There's no need for me to have a new example. Let's just go here inside this same example. In this if statement, I'm simply checking if AL Janab does exist or not. Again, if it does exist, he's simply going to show me it, tell me it does exist. If it doesn't exist, he's simply going to tell me it doesn't exist. But here's what I want to do. I want to perform a further test here. Now we know that there is a file called the password inside the etc, which hold all the usernames inside, again, inside the Linux operating system that we're using here. And what I would like to do in this case is that I want to see, maybe I forget about a character here. Like, for example, with this if statement that I have here, the AL Janab has to match exactly with that username login. If one letter is extra or less, it will not simply considered as does match. Well, so what I'm trying to do here is, if you find it exactly like the same spelling that you have for user one, then yes, it is. But if it doesn't, I want you to go and look inside the password file and see if there is something similar or close to it. So look what I can do. I can come here and type if inside the else statement, and I will type grep. Now, what I'm trying to gripping here, I'm trying to grip my user one variable, so I have to put the dollar sign. And I want to look inside the etc pass wd. And remember here, always redirect it to div and null. So if that's the case, I'm just going to type here, then, and I will type echo. And let's see, what kind of message? I'll just put a message. Maybe there is an error in the typing of the user ID. Okay. And then I'll put FI here. Or you know what? No, I'll have to put else. And I'll put this away. And most importantly here, you don't want to forget about the FI here. Again, remember this FI here is for this if statement. Okay. Now let's keep it as it is and run it. And then I'm going to come here and take one of these characters away or two characters away. Okay. So let's go ahead, skip WQ. And now if I run it, you will notice that, well, it's the same thing. So lgnab does exist. Okay. Now let's go back and try to make a different. Now remember, grep here is going to search for a matching. So I'm going to take, and I'll take this one as well. Okay. I'm taking some characters from the beginning and from the end. Now remember here, grep is going to search for all the lines in the pass files, looking for the letters L, J, A, and A. Now if I exit WQ, and if I run it, let's see what's going to happen here. Oh, here it is. Maybe there is an error in the typing of the user ID. Okay. Now, what if I actually want to see that? Let's go back here to the Vim. And actually, I want to see the results of this line. Okay, which we can. Let's go ahead and type it here. So I'm going to go and I will just type it again. $ user etc backslash pass wd. Okay. Now remember here, if this is going to lead to an error, you're not going to see anything. So let's just go ahead and give this a try. WQ. And if I run it, and here it is. He's telling me, oh, wait a minute, permission denied. Oh, I didn't think about that part. I don't have access to it, so I cannot show it on the screen. Okay, let's just go ahead and fix that. I should be able to change the permission if I want to, but I don't want to do that right now. So let's go ahead and take that away. I'll just keep it as simple as possible. The idea here again, I'm typing a username. I'm looking for the exact match for that username. And if that match does exist, it's simply going to tell me it does exist. If it doesn't exist, it's simply going to search for whatever I typed inside the password file, hoping I will find a match with those letters. And if that match was found in the password file, it's going to show me that maybe there is an error message in the user ID you entered. Otherwise, if it doesn't exist, simply is going to show me that the user doesn't exist. So let's go ahead and exit. And this time, before I actually exit, let me change to something that actually I know for sure doesn't exist. And I'm going to put, for example, V. So out WQ. Now, if I run the program, you'll see V doesn't exist. So this is another example here to show you how does it work. And this example here, I went through the process of having an if statement um, inside an if statement. And this is what we call the nested if statement. Now, nested if statement by itself, the way that I showed you, could be actually written in a little bit better way. And what I'm going to do, I'm simply going to show you how can we actually rewrite that program to make it work in a little bit better fashion. And let me just go ahead and have access to it. Now, here's the deal. And instead of, let me just go back to the sermon. Instead of having this else statement and followed with an if statement, what can we do? We can have something called elif. Okay. Now, the thing with the elif statement, if you go with that technique, then you don't need this if end of fi here anymore. So I'm just going to push those back again. Push this back, push this back, and push this back. This is equivalent to what I just did before. So here's what's going to happen, and you have to pay attention to this part. This statement is going to be executed, and if the exit status of this statement is 0, this is going to be executed and everything else will be ignored. If this statement here was not with an exit status of 0, then it's going to come here and it's going to try to execute this command. If this command here has an exit status of 0, then this is going to be executed, and this one is going to be ignored. If the exit status of this command here was not 0, then this is going to be ignored, and you're going to be simply left with this echo to be executed. Now, of course, this can go as far as you want. You can have elif as many as you want. Now, of course, this technique is a little bit more efficient, and this is in reality how it's done comparing to the previous command that I showed you. Now, pay attention here. Very, very important that in the previous technique, we needed to have two FIs. FI for the original if statement, and then we had another FI for the if statement that was inside the else statement. But if you go with this technique, you simply going to put them all together under one if-else if statement, and you will need a single FI statement there. And that's the nested if statements. Let's see if we have more examples to go about this. Okay, one sec. What I'm going to do, I'm going to give you guys a break for 10 minutes, and then we're going to continue from that point. So let me stop sharing, and let me pause recording, and I'll be here at 7:10. Okay, so I am back. I hope everybody will be back by now. I start recording. Let's start sharing my screen. Okay, let's start. Let's get back to where were we? We're going to move on now, and we're going to talk about how do we compare numbers. Now, so far, in the two examples that I showed you here, we simply just went through how do I check if a folder, a path does exist? How do I check if a user does exist? But now let's move on and talk about how do we process numbers and how we use if statements with numbers. Well, in reality, what we can do with numbers, we can compare numbers. We can check if two numbers are equal, less than, greater than, not equal, less than or greater than, and so on. Now, in the PowerPoint file that I hope everybody could have access to, there is a table that shows you how do you compare two numbers, but I'm just going to demonstrate that with an example here. So let's say we have num1. What did I do? Okay, let's go back here. We have variable num1. Let's put that 10, and let's create num2, and let's put there 20. And here's what I can do. I can say if, and pay attention to this, open square bracket, close square bracket, have a space, let's say num1 space, and we have 6 different options. You start with hyphen here, and you can put EQ for equal, GE for greater than, GT for greater than or equal, wait a minute, no, GE greater than or equal, GT greater than, LE less than or equal, LT less than, and NE not equal. Okay, so I'm going to check if they equal first. So EQ space $, num2 and a space. Now it's very, very important that you should have those spaces. Okay, otherwise it would not work. And I'm simply comparing num1 with num2 and checking if they equal. And then after this, I can come here, type then, and type else. Sorry, without before else, echo. I'll just say they are equal. They're the same. Else, echo, they're not the same. They're not the same. And then, of course, fi, don't forget. So here we go. This is again how, let me just exit and let me save my work. And of course, they're not the same. And you can see they're not the same. They're not equal. Let's go back here and let me go through those commands. Again, remember here, we can have, those are your options. And let me put them in a form of comment. We have equal. We have, oh, wait a minute, there's no dash here. Equal. We have not equal. We have less than. We have greater than. We have greater than or equal. And we have less than or equal. So those are your options that you have there. And this is how simply we compare integer numbers. Again, you can, as I said, you can replace any of these commands and just check if two numbers are equal or not equal. One of the challenges that we have in the book is simply, how can I compare three numbers to figure out which one of them is the greatest number? Well, here's what we can do. We can create a num3 to get the job done. And we'll put, let's say, 15. My job is that I want to know which one of those three numbers is the maximum number. So here's what we can do. I can compare num1 to num2 and try to figure out which one of them is the greatest. Okay. So number one equal. Instead of equal, let's just put I touched the mouse and everything went. We're going to ask if number one is greater than number two. Now, if that's the case, look what I'm going to do. Instead of showing this message, I'm going to say max equal $num1. And I will come here, else max equal num2. $num2. Now that I'm done with this first if statement, I know that the greatest value between 1 and 2, num1 and num2, is actually max. I could come here and say if, and I'll just do the same thing this time. I will put max with the $, greater than $num3 with the $. Remember here, we don't have to redirect anything in this case, of course, because again, we are not having any outcomes of those comparison operations. The comparison operations, at the end, we're going to return true or false. If it's true, then whatever after the then is going to be executed. If it's not true, then whatever after the else is going to be executed. I will come here and type then. And I will say here, max will actually equal max. Well, I simply do not need to do anything here. Because again, so all I have to do here is instead of greater than, let's go and do less than. Less than. If max was less than a num3, then max has to be updated to equal whatever num3 was. And this is going to be fi. After that, I can echo $, max, and that will show me the greatest value out of those three. Let's skip, exit, and let's run it again. And you can see if 20 is the greatest value. I forgot if 10 was the greatest value, and yes, 20 is the greatest value. So this is how we can figure out which one of those values is actually the greatest value. Let me continue. Wait a minute. And you know what? It looks like, let me just add a little bit space here. Let me go all the way up. Now we're going to move on and talk about how do we work with floating numbers. Because again, the technique that I just showed you here, and we learned that from the previous class, that only works with integers. So what do I do whenever I want to compare numbers with the floating points, with a decimal point? Now, as let me just tell you here, it will not work if you have a variable, let's say variable, let's call it num4, and let's say 5.89. It's, of course, it's acceptable to have a variable like this, but you cannot use the same technique that we had before. For example, if $sign num4 was, let's say, greater than, let's say, 10. This simply will not work. Okay. So what we should do to make this works, we have the very same technique that we used when we dealt with the floating numbers in the previous chapter. Only this time, here's how it's going to work. Take all this away. And we're actually going to be using the symbols of greater than and less than instead of typing GT or whatever the command that we had there. So the idea here is that, and it's very, very important to understand, the command here is the command is going to be a little bit long, but I want you to pay attention to how is that going to work. We are going to have those square brackets. Let's just put it that way. And then inside the square brackets, this is what we're going to do. We're going to start with putting a $sign, and we'll open a parentheses, and we're going to type echo. And then after that, you put between double quotations, what are you trying to do here? For example, $sign num4 space greater or equal, let's say, 5. Okay? And as we are still inside the parentheses, we type the BC, so we know that we are simply going to be calling the BC to process the decimal point arithmetic here. Now, at this point, what we should know about this, if the final outcome of this expression could be 0 or could be 1. 1 simply when it is correct, 0 when it's false. So all I have to do after that is to compare it with 1 and space. It's a really, really long, twisted story to compare decimal points. But if you think about it, this term by itself is going to be evaluated as true or false, or let's just put it this one or 0. 1 for true, 0 for false. Simply means if num4 was greater or equal 5, then the final evaluation for this statement here is going to be 1. And what am I going to do with that one? I'm going to compare it to 1. If it matches, then simply means we got it correctly. So we'll type then, and then we type echo, and we'll say it is. We'll just put it here as num4 is greater or equal 5. Of course, I can come here and say else echo $ num4 is less than 5. Because again, if it's not greater or equal, then it's less. NFI. Let's go ahead and give this a try. Clear. And you can see here, 5.89 is greater than or equal 5. And that worked. So the idea here is then to do a comparison with integers, the idea is very simple. You need to have those square brackets. You have to pay attention to the spaces, and I can tell you, you will have issues with those spaces. So please pay attention to those spaces. But if you have decimal points, all you have to do is to have the same square brackets, and at the left side, the right side, you type equal 1. But in the left side, you type the $, you open a parentheses, and you perform the operation using the echo, which again, and using the BC to make sure that the final outcomes, again, for that expression, it's going to be 1 or 0. If it's 1, it's going to match the 1. That's going to be considered true. Otherwise, it will be false. And that's how we simply compare numbers with decimal points. Now, how do we compare strings? Compare strings, and let me see how much left. Well, looks like we still have a lot to cover. We'll see how far we can go with this chapter. Time is it? Yes, I still have like I don't think I want to cover the whole thing today. So we're gonna cover half of it, and the next class we're gonna cover the other half. And I'm gonna make sure to provide you guys with more examples. Let's see how things are gonna go. How do we compare strings? Let's go to Vim again and see how do we compare strings. And I'm going to have a screen divider here as well. Oops. Compare strings, we are simply going to be using the same technique that we have with using those square brackets, and we can compare the strings using equal, not equal. Let me just go back here to make sure that, again, I'm pretty sure you guys already know this, but just in case you don't, let me put it here. We have a greater than, we have less than, we have greater than or equal, we have less than or equal, we have not equal. So how many of the 1, 2, 3, 4? Am I missing anything? There should be 5. 1, 2, 3, 4. Less than, equal, not equal, less than. Oh, equal. I forgot the equal. So let's go back here and put the equal. Talking about equal, make sure here you put the double. Let's make sure that that's the case before I jump into conclusions. I think, yes, it is. Because otherwise it's going to be assignment operator. So double equal. Now with strings, it's going to be a little bit different. And let me show you how strings works. I just want to push the text down. So we'll use the upper side of this text file. To compare strings, we have the following operators. We have equal, we have not equal, we have less than. But remember here, whenever you want to do less than, you have to type it this way. And we have a greater than. This is how it works. And we have, what else do we have? We have, if the length actually has 0 character, so the size of it is 0. So hyphen z, and we have hyphen n, which simply means there are some characters in the string and it's not empty. So those last two operations, simply we use them to check if the string has characters and or if the string has no characters. Okay, with that being said, how do we compare strings? Well, the idea is very simple. All we have to do, type an if, open square brackets, and you tap your first string here. We'll call this one ABC. And then after that, what are you trying to do? We're trying to compare it to, let's say, less than, I will say, A, B, D. Okay. Now, this is, you have to pay attention to this because this could be a little bit confusing. How do we compare strings using, I know equal and not equal is very simple and very easy. If two strings are exactly the same, then that's true. The exit status is zero. Otherwise, it's false. Here's the deal. When you compare strings with less than, what are we doing here? We simply compare each character with the corresponding character. So we're comparing this A with the A, and B with the B, and then C with the D. Now, what am I doing here in this case? I'm asking myself if C in the alphabetic order is less than the D in the alphabetic order. Okay, so that's what I'm doing here. Simply means that I'm checking here. Let me just make sure that I'm getting this right. Yep, I'm checking here if the ABC here comes before ABD in the alphabetic order. And if the executions of this command give me a status of 0, that simply means it's true. So I can come here and type then, and then let's echo, and we'll say ABC comes before ABD, else echo ABD comes before ABC, and then FI. This is how simply we compare those two strings, and we can do less than, what's very, very important to pay attention to the fact that less than simply means ABC again comes before ABD in the alphabetic order. And how is the bash scripting performing this operation? It's simply, again, simply comparing each character with the character corresponding to it. So A, same A, is going to pass it. B and B is going to be passed. And then it's going to look for the character that is not in the same, not the same in both strings. In this case, C and D. And since C comes before D in the alphabetic character, so the first statement is simply going to be executed. If, for example, I have ABC and ABC, simply again, it's not going to be considered that ABC is before ABD. They're considered the same. Okay, so let's give this a try and see how is that going to work. And pay attention here. Upper cases make a major difference here. So uppercase A is not as the same as lowercase a. And what you should know, how is this performance comparison performed? Every single character has an ASCII code, which is again a decimal value. And those characters are compared based on their decimal values. And uppercase characters has lower values than the lowercase. So uppercase A decimal value is less than the lowercase a decimal value. So let's go back here and run it and see what's going to happen here. And ABC comes before ABD. That's exactly what I thought. So what we learned so far, let me just put it that way. We learned how do we check using if statement for a user if it does exist. We checked how can we check if a path does exist, and then we moved after that to numbers, and we learned how do we compare numbers, the integer numbers, and then we learned how do we compare numbers with decimal points, and now we learned how do we compare strings. And remember here, let me go back to the same example here because I should be able to cover all the possibilities. And the possibilities goes as following. Well, here's the deal. If I'm comparing two numbers, there's a chance that one of them is greater than the other, or one of them is less than the other, or they're exactly the same. So here's what I can do. I can come here and type if, and I'll say ABC equal ABD. Now, what is going on here? then echo, both are the same. All I have to do after that is to come here and type elif. Okay. And then it's going to compare for this case, and it's going to, now I'm just confused here. Why is this ABD change color? Let's go back here and try to fix this. ABD. Let me use double quotations and see if that's going to make any difference. Because that color code gave me a bad impression that this will lead to some sort of problem. Okay, both are the same. If, elif, then else, if I think I got it right. Let me make sure that I got this. Okay, let's get out of here and see if that's going to make a difference here. ABC comes before, of course, it is. That is correct. Let's go ahead and change it to ABC. Make it this, both of them are the same. And both are the same. So it simply worked with no problems. Okay, now just like I said, we can do the not hyphen N and hyphen Z to check if there is any character inside a string. Okay, so let me see here. The part that is left is how do you test if a file does exist and checking if you can write to a file. And there is also the logical operators. Here's what I'm going to do. I am going to stop at this point. And the remaining of this class, I am simply going to have to create a video for it and post it later. Now let me just stop sharing and stop recording.